Welcome students, this is indefinite integration lecture number 21. In today's lecture we will see one or two new type of integral problems. So the first one here we have is integral of the type. So I teach you today integral of the type e raised to x f of x plus f dash x dx is equal to e raised to x into f of x plus c. So what is the type? The type is if you have an integrand. What is this? This is integrand. You know, something that you are integrating is integrand. Okay, and now this integrand is a special integrand. Why special? Special because see here what you have. You have e raised to x multiplied, you have e raised to x multiplied 2. You have e raised to x multiplied 2. Sum of two functions where one of them is the derivative of other. Where one of them is derivative of other. And when you have any such integrand, then what is the derivative? The derivative is e raised to x into f of x plus c. So what was the integrand here, students? The integrand was e raised to x multiplied to two functions, and you notice that f dash x is derivative of f of x. It is derivative of f of x. So the integration of complete integrand is nothing but e raised to x into f of x. What is it equal to? It is equal to e raised to x into f of x plus c. So let me give you an example for this. See, for example, if you have integral e raised to x sine of x plus cos of x. So what you notice, look at the integrand. What is it? You have e raised to x multiplied to sum of two functions, and you notice that one of them is derivative of other. So see, this is your f of x and this one is your f dash x. So as per the result, what will be the answer for this? The answer is e raised to x into sine x. That is e raised to x into f of x, not f dash x. Please don't write e raised to x into cos x. E raised to x into sine x. Cos x is derivative of sine x. So here f dash x and f of x. So what is the answer? E raised to x f of x plus c. Okay. Let me give you one more example. E raised to x log of x plus 1 over x dx. So what do you have here? You have e raised to x multiplied to f of x plus f dash x. So e raised to x f of x. That is e raised to x into log of x plus c. Okay. So let us solve few problems based on this type. Let us solve few problems based on this type. So here, the book which I am referring, in that I have third, it is exercise 3.3. It It is exercise 3.3, third, first. So here I write let I equals to, they give me the integral, I have to evaluate it. So it is integral 2 plus cot x, 2 plus cot x minus cosec square x, 2 plus cot x minus cosec square x into e raised to x dx. Okay, so here what we will do is I will write 2, I will take this 2 as one term, and this cot x minus cosec square x in one bracket, and then e raised to x. In the next step, I multiply this e raised to x with both. I multiply e raised to x. I multiply e raised to x to 2. I multiply e raised to x with cot x minus cosec square x. So here I get, therefore I equals to integral 2 e raised to x, and here I have e raised to x cot x minus cosec square x bracket complete and dx. Now I shall write separate integral. So I will have I equals to integration of 2 e raised to x, integration of 2 e raised to x. So when I write integration of 2 e raised to x, 2 is a constant out. So 2 is out. I will have e raised to x dx. I will have e raised to x dx plus here I will have e raised to x cot x minus cosec square x and dx. So the result which I just taught you, this result, okay, this particular result which I just taught you, okay, this is going to be used for this, not for this. Okay, not for this, it is for this. Now how will that be used? Some of you might be thinking that we don't see the function and its derivative. Do not worry, I shall make you see that. So see here, I will write 2 times integral e raised to x dx, the first one, plus integral e raised to x, and the bracket, inside the bracket, see what I have. I have cot x minus cosec square x. I will write this as cot x plus minus cosec square x. I have cot x plus minus cosec square x dx. So see what I have. I have f of x plus f dash x. See, this was cot x minus cosec square x. I can write, if I have a minus b, I have full right to write a plus minus b. So this is how I wrote it. Okay. So I have written it this way, and then see what I have. So I have here cot x plus minus cosec square x. So this is in the form e raised to x, f of x, this is f of x, the function, and what is this? This is f dash x, the derivative, cot x, and it is derivative of cot x, which is minus cosec square x. Okay, so the next step I write here using e raised to x, f of x plus f dash x dx equals to e raised to x into f of x plus c. We get, what do we get? We get I equals to, this one is straightway 2 e raised to x, and here I get e raised to x into cot x plus c, e raised to x into cot x. What is integration of this? It is e raised to x cot x, that is e raised to x f of x plus c. So I take e raised to x common, so I get I equals to e raised to x. When I take common, I get 2 plus cot x, 2 plus cot x plus c. This is answered. We could have done this problem. We could have done this problem more faster had we considered 2 plus cot x as f of x. Like, what did I do here? I multiplied e raised to x with 2 and I multiplied e raised to x with cot x minus cosec square x. That was okay, but if I wanted, I could have taken 2 plus cot x as f of x, because derivative of 2 is anyway 0. Derivative of 2 is anyway 0. So as you say, derivative of cot x as minus cosec square x, derivative of 2 plus cot x would not make any change. So see how what I'm saying. Second method, which is faster method. So here I write, let I equals to integral 2 plus cot x minus cosec square x. What will I do here? I will write this as integral 2 plus cot x in one bracket, and this is minus cosec square x. I'll write plus of minus cosec square x. So you can see how fast I can solve. I forgot to write e raised to x. So here that e raised to x is there. So we have e raised to x multiplied and dx. Okay. So, and I write e raised to x here. It is and dx, right? So now what I can say we have e raised to x into f of x. See, this is f of x, plus we have f dash x, plus we have f dash x, f of x plus f dash x. So what will be the derivative? Sorry, what will be the integration? Answer will be e raised to x into f of x. Okay, so here I write using the result, that is e raised to x, f of x plus f dash x dx equals to e raised to x, f of x plus c. So what we get therefore I equals to e raised to x into 2 plus cot x plus c. This is answer. E raised to x, 2 plus cot x plus c. This could be done much faster. So here I give you a problem for practice. I solve the second question, that is second from second. Let I equals to, we have 1 plus sin x divided by 1 plus cos x multiplied to e raised to x and dx. I will write this as I equals to 1 plus sin x divided by 1 plus cos x. I write 2 cos square x by 2. This is well-known formula. You all know it. 1 plus cos is 2 cos square. 1 minus cos is 2 sin square. And whatever angle you have with cos, you will write half of this. So here I had x. I wrote x by 2. If I had 2x, I would write x. Okay, write half. So x, and here we get x by 2. And here you have e raised to x dx. The next step, what I do is I separate this denominator. So when I do that, and let me also write e raised to x in the beginning. So I have e raised to x, and this e raised to x I wrote in the beginning, e raised to x, and see here I separate the denominator. So this is 1 upon 2 cos square x by 2 plus sin x upon 2 cos square x by 2 plus sin x upon 2 cos square x by 2. Okay, what now I do is next step I will write the I will write half angle formula for sin x. See, I split the denominator for this two terms. So I got 1 upon 2 cos square x by 2, sin x upon 2 cos square x by 2. And this sin x, I write the half angle formula. What is sin x? It is 2 sin x by 2 cos x by 2. So I will get 2 sin x by 2 into cos x by 2. This is what I will get. Okay. So next step, what will happen? This 2 and 2 cancels, and 1 cos x by 2 also gets cancelled. So I get here I equals to, I get here e raised to x, and I get here 1 upon 2 sec square x by 2. Okay, 1 upon cos square x by 2 is sec square x by 2. So I get 1 upon 2 sec square x by 2 plus sine upon cos is tan. So plus tan x by 2 and dx. Okay. So now you can check what's happening here. Inside the bracket you have tan x by 2 and half sec square x by 2. Now you know derivative of tan x is sec square x. So I understand that this could be f of x, though I am not sure about it. I will make myself sure after solving. So I understand that this could be f of x, and here this could be f dash x. Okay, I'm saying could be because I'm not yet sure about it. Okay, so what I will do is I will check this, I will confirm this by actual differentiation. Okay, so I will confirm this by actual differentiation. So here, see, I write d by dx of tan x by 2. Let us differentiate tan x by 2 is equal to, now you know the function is tan, but the variable is not matching. It is x by 2 and here you have x. So what will be the derivative here? The derivative will be, it is not d by dx of tan x, rather it is d by dx of tan f of x. So d by dx of tan f of x will be sec square f of x into d by dx of f of x. So this is sec square x by 2 into d by dx of x by 2. So this will get you sec square x by 2 into d by dx of x by 2. 1 upon 2 is constant, and you have d by dx of x. So you have, finally you have 1 upon 2, because this is 1, d by dx of x is 1. So you have 1 upon 2 sec square x by 2. And what you notice that the other term inside the bracket is same. It is same, 1 upon 2 sec square x by 2. So now I understand this is my f of x. Now I'm sure about this is f of x and this is f dash x. So I write here using e raised to x, f of x plus f dash x, f of x plus f dash x dx equals to e raised to x f of x plus c. We can write what we can write. Answer for this is, what is answer for this whole thing? It is, you understand, this is e raised to x, here it is f of x, here it is f dash x. So answer is e raised to x f of x. Okay, so answer is I equals to e raised to x into tan of x by 2 plus c. This is final answer. Please copy this, practice it well, see the whole solution once again. So let's quickly solve one more problem. Let I equals to x upon x plus 1 the whole square into e raised to x and dx. So for this, what I will do, I'll write, first of all, I'll write e raised to x in the beginning. So I will have e raised to x, and then inside the bracket I have numerator x, so I write x. Look at the denominator. Denominator is x plus 1, so you should always write numerator in such a way that you get the content of the bracket up. So you write x plus 1 minus 1 upon x plus 1 square. This is the way you write, and then you have dx. So next step, what you do is you split this denominator. X plus 1 square you split. You split for this and this. Okay. So see, what do you get? You get I equals to e raised to x, and you get x plus 1 upon x plus 1 square, and here you get minus 1 upon x plus 1 square and dx. Okay. So what do you get? You get 1x plus 1 cancelled, right? Because you have here you have numerator you have x plus 1 and the denominator you have x plus 1 square. So 1x plus 1 will cancel. So you will have therefore I equals to e raised to x, and you have here 1 upon x plus 1, and this one I write as plus minus 1 upon x plus 1 square. And remember students, as we have done, as we have as we know that d by dx of 1 upon x is minus 1 upon x square. As we know, d by dx of 1 upon x is minus 1 upon x square. So d by dx of 1 upon x plus 1 will be, see, this is 1 upon f of x. What is difference between these two functions? What's the difference between the two functions here and here? Both are same functions, but in this you have variable as x, and here the variable is f of x. Both the functions are reciprocal functions. They are reciprocal functions. So this goes by basic definition. So such function we call d by dx of 1 upon x, and here we will call d by dx of 1 upon f of x. So derivative of 1 upon f of x will be minus 1 upon f of x square into d by dx of f of x. So minus 1 upon, what I will get here? I get here minus 1 upon x plus 1 square into d by dx of x plus 1, which is 1 plus 0, which is 1. So finally we will get d by dx of x plus 1 will be 1. Okay, so this has no say as such, so you can just ignore it. So what you notice that this will be my f of x. This is my f of x here, and so I can call this as f of x, and this is f dash x, f of x and f dash x. Okay, so I go ahead and write using the result. I write here, since d by dx of this is this, therefore using the result. What is result? We use e raised to x, f of x plus f dash x dx equals to e raised to x, f of x plus c. We get, what you get students, you get answer as I equals to e raised to x into 1 upon x plus 1 plus c. Okay, that is e raised to x upon x plus 1 plus c. Okay, so here we have some practice problems. Now these all problems are to be solved by the same result which we learned just now. What we will do is, in the first one we will write 1 plus cos 2x as 2 cos square x. Then we will split that 2 cos square x for 2 and sine 2x. We will also have to use the formula for sine 2x, and then you will get where after writing sine 2x formula, you will get the proper expression where you can use e raised to x into f of x plus f dash x dx is equal to e raised to x f of x plus c. Same thing here you will do. Here you check that in numerator you have x plus 2 and denominator is x plus 3. So you will add 1 and subtract 1 so that in the numerator you get what you have inside the bracket in the denominator. And in this question you will multiply 1 upon x inside the bracket. So 1 upon x will multiply this and it will multiply this. When 1 upon x multiplies this x will cancel. You will have simply log x the whole square, and here you will have 2 log x upon x. Now when you differentiate log x the whole square, you will find that d by dx of log x the whole square is 2 log x into d by dx of log x, which is 1 upon x. So that way you will be able to solve this. I take few more problems for the similar type where we will now use substitution. I'm going to use substitution. So let me take question number. Now the book I'm using, it is question number 7 here. So I write 7. Let I equals to e raised to tan inverse x, e raised to tan inverse x, and I'm sorry, it's not tan inverse, it's actually sine inverse. So e raised to sine inverse x, and I have inside the bracket I have x plus square root of 1 minus x square, x plus square root of 1 minus x square upon square root of 1 minus x square and dx. Okay, so see what I do. I notice that here I have in the power I have sine inverse x. Okay, now this is bad power. It is not a good power. What it is bad. Why it is bad power? See, if I'm integrating with respect to x, then I will definitely want e raised to x. So if I see anything other than x in the power, it is bad power. So as per my concept, what I do, I put bad power as t. So put sine inverse of x equals to t, and now I write differentiating with respect to x. So I get d by dx of sine inverse x, which is 1 upon square root of 1 minus x square into d by dx equals to d by dx of t. Now this dx I multiply here. So I have dx upon square root of 1 minus x square equals to dt. Now because of this, what will happen, students? See, now here you can check. Now here you can check that this part, which part? Dx upon square root of 1 minus x square. This whole thing I will be writing dt. Okay, and this I will write t. This I will write t. But still this part is left which needs to be converted into t. Remember, once you substitute sine inverse x as t, the new integral which you will write, it will have dt, and hence everything here should be in t. Okay, and that new integral you write based on the old integral. So see here what I will write. I will write therefore I equals to, I will have here I equals to e raised to t, sine inverse x is t, so e raised to t, and then you know that this part is dt. Which part is dt? This part is dt. So here you write dt, you write dt here, and dt has covered this part. So still which part is left? This part is still left to be converted into t. Okay, so see, for that what I will write. From here I understand if sine inverse x is t, so x is sine of t, x is sine of t. So see, now I write here sine of t, sine t plus square root of sine t plus square root of 1 minus sine square t, and then here I have dt. Okay, so I got here e raised to t, I'm sorry, this is e raised to t sine t plus root of 1 minus sine square t. 1 minus sine square t is cos square t, and then dt. So the next step I get is, therefore I equals to e raised to t integral e raised to t sine t plus cos t and dt. Now I have e raised to t, I have e raised to t, f of t and f dash t. Okay, derivative of sine t with respect to t is cos t. And remember, here everything is with respect to t. It is not with respect to x here. So I shall write here what? I write here using the result. What is the result? The result is e raised to t f of t plus f dash t equals to dt equals to e raised to t into f of t plus c. We get what we get? We get I equals to e raised to t into sine of t plus c. And what is t? t is sine inverse x. So finally I get here I equals to e raised to sine inverse x. Okay, and when I write here sine of sine inverse x, I will get x plus c. So the final answer is I equals to x into e raised to sine inverse x plus c. This is final answer. Thank you. You can watch this all once again and solve it to have proper practice. Solving makes you perfect. Some more problem for practice I have written here. So you can solve these problems. They will use the similar method. Here you will put tan inverse x as t, bad bar. And this problem is a bit challenging. What you will have to do is, I give you the hint here. The hint is, it is x square plus 1. So in the next step you write x square minus 1, okay, plus 1, and already plus 1 was there, you know. You write this plus 1 because you wrote minus 1, and this plus 1 is already there. So this is what you will do in numerator, and the denominator will remain same. It is same denominator. Then in the next step you will write then x square minus 1. This you will write it as 1 square. So, and then you will separate that denominator. That e raised to x will always be there, you know, outside. This is something that you are manipulating only inside the bracket, like this one. Then you will split this x plus 1 the whole square for x square minus 1 square, and 1 plus 1 is 2. You will split it this way, okay? This is 2 here, 1 plus 1 is 2. So what do you get? You will get here e raised to x, and then x square minus 1 square upon x plus 1. So x square minus 1 square is x minus 1 x plus 1. So 1 x plus 1 will cancel, and you will write x minus 1 upon x plus 1. And here you will get 2 upon x plus 1 the whole square. And then dx will be there and integral will be there. Now you will be surprised to know that this is your f of x and this is f dash x. So you will actually differentiate there, you know. You, in order to make yourself sure, you will write d by dx of this complete thing. You write x minus 1 upon x plus 1, And you will notice that d by dx of x minus 1 upon x plus 1 comes out to be 2 upon x plus 1 the whole square. It comes out to be 2 upon x plus 1 the whole square. Okay, and that's it. That will be your answer. This is a good problem. You should practice these problems. So I think this much is enough for this type. Or yeah, one more problem we shall take. That is question number, the book which I am solving, it is from that book, it is question number 9. So I write here, let I equals to, it is cosec log x, and multiplied by 1 minus cot log x, cosec log x multiplied by 1 minus cot log x and dx. So here, bad angle, cosec log x. Log x is the angle which is definitely not a proper angle for us. In integration, if we are integrating with respect to x, then I would like to have cosec x, not cosec log x. So I call that as bad angle. So these two are bad angles. Okay, and whenever I see bad angles, I put that bad angle as t, right? So I write here, put log of x equals to t. So if log x is t, I differentiate with respect to x, and d by dx of log x is 1 upon x. d by dx of log x is 1 upon x. No, I'm sorry. I will not do this. So what will I do? I will not differentiate with respect to x here. Instead, now see students, after I putting log x as t, we all know what is the base. What is the base here? We all know the base is e. In calculus, the base is e, which we do not write. It is understood that log of x, the base is e. Then I use the definition of logarithm. We all know if log x to the base e is t, then x would be e raised to t. Then x would be e raised to t. This we all have done, logarithmic form and exponential form. You have done this in 11th standard when you learned logarithm. So for a few of you, let me now explain this. See, if a raised to b, equals to t, then log of t to the base a is b. Okay, so it is true both the ways. If this, then this, and if this, then this. So here we have, how have we worked here? We are working in this direction. So see, log t to the base a is b. So what is t equal to? T equals to a raised to b. T equals to a raised to b. So this is definition of logarithm which we have used here. And see, so the next step, I get x is e raised to t. Now I write differentiating with respect to t. Even you could have differentiated with respect to x. That does not make many difference. So here we have d by dx, we have d by dt of x. I'm differentiating with respect to t, and d by dt of e raised to t is e raised to t. Now I multiply dt here, so I have dx is equal to e raised to t. I have dx equals to e raised to t into dt. Okay, e raised to t into dt I have. Now I will write the new integral. Okay, so let me first take this off. Yes, I will now write new integral, and what will that be? So I have here I equals to integral cosec log x. What is log x t? Cosec t inside the bracket 1 minus cot log x. What is this? This is cot t, because log x is t. So cot of t, cosec t into 1 minus cot t, and dx. What do I write for dx? Dx is e raised to t dt. So see, the next step what I do is this cosec t which I have outside the bracket, I would take inside it. So you know, I get multiply this cosec t inside the bracket. So you get cosec t minus cosec t into cot t e raised to t dt. I write e raised to t in the beginning. So e raised to t, and then see how do I manipulate the bracket, the terms in the bracket. It is cosec t, it is negative of this. So, you know, I write plus negative cosec t cot t, cosec t cot t and dt and dt. So what will happen, students? Now what happens here is this is my f of t, and see d by dt of cosec t is minus cosec t cot t. This is my f dash t. Okay, so here I get therefore, okay, I think I committed a mistake here, and that is it should be t not x. Yeah, sometimes this happens, you know. So this is t. Now I write using the result. I write here using the result. Which result? You know it already. Using e raised to t f of t plus f dash t equals to dt equals to e raised to t f of t plus c. We get what we get, students. We will get I equals to e raised to t f of t, that is e raised to t into cosec t plus c. And what is e raised to t? E raised to t here is x. You know, for e raised to t I can directly write x. So my final answer is I equals to x into cosec t. T is log x. X into cosec log x plus c. This is my final answer. You can see the whole thing once again and practice this problem. You can get similar kind of many problems from the book or the notes, whichever you are referring to. Thank you. Okay, so now let us start with a new type of integral problems, and that is integration by partial fraction. Okay, this is quite interesting. Many questions come in different types of boards, that is respective state board you are in, or CBSE or ISC, and even problems in JEE and different entrance examinations are covered on this type. Very interesting type. So this is integration by partial fraction. So before I teach you integration by partial fraction, or what this type of integral problems are, there are few basic prerequisites. Prerequisites means something that you need to know before you start learning something. So before we start learning partial fraction, we need to know something which let us know. So see here, students, I have here f of x upon g of x. I have here f of x upon g of x. I have a function here which is in the form f of x upon g of x. Like you have, suppose you have 2x square plus 1 upon 3x square minus 5x plus 7. So what is it? It is f of x upon g of x. So something like this you have. Okay. But f of x and g of x both are polynomial in x. See the way I have written, like you cannot have something like this, you know, sine x upon 2x square plus 7. No, not like this. Why? Because now the numerator is not a polynomial in x, it's a trigonometric function. So that is to be understood, that here what we are referring to is strictly polynomial in x upon polynomial in x. Okay. It's a different thing that degree of the polynomial in numerator and denominator could be different. Like here what I noticed, that degree of polynomial in numerator is 2 and the degree of polynomial in denominator is also 2. I hope you all know what is degree of a polynomial. It is the highest power of x that you see in the polynomial. It is the highest power of x that you see in the polynomial. So both are 2. So degree is 2 for numerator and denominator. See, I could have had x plus 1 upon x square plus 5x plus 6. See, this is, now here what I notice that degree of polynomial in numerator is 1 and the degree of polynomial in denominator is 2. Okay, so I hope this much is clear to you. So where were we? I was teaching you that we have a function which is in the form f of x upon g of x, where f of x and g of x both are polynomial in x. Now such a function that is f of x upon g of x form, such a function is known as a rational function. What we call this as? We call this as a rational function. Okay, ratio of two polynomials, and hence we call this as rational function. Some teachers and students also call this as rational fraction. Rational fraction. Okay, I hope this much is clear to you. Now let's move ahead. Now here we have rational fraction. So what was that rational fraction, my dear students? It was f of x upon g of x. It was f of x upon g of x, and where both f of x and g of x both were polynomial in x. Okay. Now remember that rational fractions are of two types. So here we have, see, there are two branches from rational fraction. One is proper rational fraction and the other is improper rational fraction. So what is proper rational fraction and what is improper, that I will now teach you. See, you know a rational fraction is f of x upon g of x. F of x is numerator and g of x is denominator, and both are polynomial in x. Okay, so they are both polynomial in x. Polynomials in x. Okay. Which kind of rational fraction is a proper rational fraction? See here. Okay, if you notice that degree of polynomial, if you notice that degree of polynomial in numerator, let me write in short as nr. If you notice that degree of polynomial in numerator is less, it is lesser, degree of polynomial in numerator is lesser. Okay, I will take less space to write this so that it will be more clear. See, if you notice that degree of polynomial in numerator degree of polynomial in numerator is lesser than degree of polynomial in denominator. Okay, then such a fraction, rational fraction, you will call it as proper rational fraction. So for example, if you want to write some example, you can write this as, see here, x plus 1 upon x square plus 7. It is a proper rational fraction because numerator is 1 degree and denominator is 2. X square plus 7 upon x cube plus 3x square plus 2. See, the degree in the denominator is 3 and here it is, numerator is 2. So degree of numerator polynomial is lesser than the degree of denominator polynomial. So it is a proper rational fraction. Now we come to improper rational fraction. What kind of rational fractions are improper? So here we have, see, if you notice that degree of polynomial, I'm sorry, degree of polynomial in numerator is greater or even equal to the degree of polynomial in denominator, then what you call such fraction as an improper rational fraction. And if you want to go for the example, then examples would be like, see here, I have x square minus 1 upon x square plus 2x plus 3. Now what you notice that degree of numerator and denominator are equal, so it is an improper fraction. If I have like this, see, I have x cube plus 3x square plus 2x plus 5 upon x square plus 5x plus 6. Now this is improper. Why? Because the degree of numerator is greater than the degree of denominator. So I have explained you what is a rational fraction. I explained you what are two different types of rational fractions. This concept is very important for learning the method of partial fraction for integration. Okay, you can see the whole thing once again. So just now I taught you what is rational fraction, and rational fractions are of two types: proper rational fraction and improper rational fraction. Now before we go for integration by method of partial fraction, this is all prerequisites that we are doing. Before starting with the partial fraction method, there are certain things that we need to know, and we are working on this. So there is a warning. That warning I shall now make you all understand. See, what's the warning? The warning is integration by method of partial fraction can be applied only on proper fractions. Remember. So when you see a proper fraction, suppose you are asked to integrate something, you are asked to integrate a function, and you notice that it is a proper fraction, then only you can apply integration by method of partial fraction. Partial fraction method you can apply only when it is a proper fraction. Remember. Now listen to the next statement. If a rational fraction is an improper fraction, okay, you must be thinking that we can apply the partial fraction method on proper fraction. What if I get improper fraction? See, if a rational fraction is an improper fraction, then we will first convert it to a proper fraction. Improper fraction, what we will do, we will convert it to a proper fraction and later apply the method of partial fraction. Why? Because partial fraction method can only be applied on proper fraction. It can be applied only on proper fraction. So this thing you will have to know. And what is the method to convert improper fraction to proper fraction? That I will tell you shortly. Do not worry about it. For converting an improper fraction to a proper fraction we will apply long division method. Okay, and this I will tell you by taking an example. See, for example, suppose I have here x cube plus 2x square plus 3x plus 1 divide by x square plus 5x plus 6. Now this is definitely an improper fraction. I want to convert it to a proper fraction. So what I will do, I will go for actual division, I will divide. So here I have x cube plus 2x square plus 3x plus 1, and I will divide it by x square plus 5x plus 6. Now I have written the powers in descending order, so as the powers in descending order here. What is this? This is a dividend. And what is this? This is divisor. Okay. So you will make sure that you are writing the powers in divisor and dividend both in descending order. Now I notice here that here the highest power is 3 and here it is 2. So it will go x times. Okay. X cube and x squared. So it will go x times. So what will I get here? X into x squared. I get x cube. Okay. I get here x cube plus I get here 5x squared. I get here x cube plus 5x squared plus 6x. And then what is next step? We subtract. We subtract. So when I subtract minus, minus, and minus, see this is gone. Here I get minus 2x squared. I get here minus 3x squared minus 3x plus 1. Okay. Now check. This is minus 3x squared and here I have x squared. So this is minus 3x squared and this is x squared. So what will happen? This will go minus 3 times. Now multiply. So minus 3x squared, I get here minus 3x squared, and here I get minus 15x, and then here I get minus 18. Okay, this one was copied as it is down here. So here I get minus 18. Minus 3 into 6 is 18. Now what's next step? We subtract. So here, see, this is subtracted, so the sign will change. Plus, plus, and plus. This is gone. So here what you get? You get here 12x. You get here 12x plus 19. 18 plus 1 is 19. Now notice, here you have x power 1 and here you have x power 2. So you will not divide anymore. No division anymore. Remember, no division anymore. That's it. So what will you do? You will now write this. See, you had this thing which you solved by applying long division method. Now you can write this to be equal to, say this will become equal to, remember, quotient. What was quotient? Quotient is x minus 3. It will be equal to x minus 3, quotient plus remainder. What is remainder? 12x plus 19 upon divisor, x square plus 5x plus 6. Now you can check. You can check here, students, that here you had an improper fraction. What you had? You had an improper fraction here. Okay, what did you do? By applying the long division method, now you have converted it into a proper fraction. And you know, students, this is a proper fraction. You can check. You got here x plus x minus 3, which is not a fraction, so it is not a rational fraction, so you're not worried about it. But where we have a fraction, it is a proper fraction. Why? Because degree is 1 and here degree is 2. Okay, so when we have an improper fraction, before applying the method of partial fraction, we apply long division method and we write it this way. So the formula here is, dividend upon divisor. Okay, dividend, the formula is dividend upon divisor is equal to quotient plus remainder upon divisor. Quotient plus remainder upon divisor. Okay. Even if you forget this formula, I shall tell you one very simple trick to get this. And the trick is, you know, you think of any improper fraction. Say for example, you think of 27 divided by 17 or 27 divided by 13. Okay, so now this is improper because numerator is greater than denominator, though it is not in x, but this is also an improper fraction. So what you do is you now apply long division method. So here you have 27 and here you have 13, so it will go 2 times. You get 26, you subtract, you get 1, remainder is 1. So now what you do is 27 by 13, is it not 2 plus 1 upon 13? You can check 2 plus 1 upon 13. 13 is the denominator. 2 13s are, or 13 2s are, 26 plus 1, 27. So you get, this is 27 by 13. So this way also you can remember, it is always numerator upon denominator is quotient plus remainder upon divisor. Okay, so students, what did I teach you in this part? Here I taught you how to convert an improper rational fraction to a proper rational fraction. What are the improper rational fractions? When the degree of numerator is greater or even equal to the degree of denominator. Suppose here I had 3, numerator is degree 3 and denominator is 2, so I divided. If I had here 2, okay, I would have still divided. Because numerator degree has to be smaller, then only it is proper rational fraction. Having done this, we have done everything required for starting with the partial fraction. I shall be now teaching you the method of applying partial fraction and how many different types of rational, how many different types of partial fractions we have in our syllabus, and then we will solve some problems. So that we will see in the next video lecture. For now, it's bye. Thank you so much.